if you finish early on the do first, since it's just multiple choice and it's, if you remember what to do from unit 1 for f of g of x, it's not that bad. Then be looking over your unit circle, because today we're doing quadrant 1 and 2. But I want you first to focus on the do first. No, because things are getting more challenging if you do more civil adjuncts. Even better, since it's harder, it makes sense that you learn unit 1 quarter 1 to Sorry, Josh. Right. And then when you finish, like I said, I got some things to pass back to y'all. So just start studying your unit circle for our little unit circle quiz. Anyone see one? Here's your one from yesterday, so you can see how you did. Yeah, so everything to 180. What? You know, just passing everything around. Your old seat. No, what are you used to say? Oh no, you're back there. Still not used to these chairs.
Easy way to remember this pie. Ouch.
Okay, go ahead and put away these ones that I passed back to you and your yellow unit circles, because we're going to do quadrants 1 and 2 today. While you're working on that, I'm going to pass back your quizzes from Friday and any problem sets that I got from yesterday. So I'm going to keep passing, but y'all put those unit circles away because I'm going to pass out now the blank ones, and I'm going to only pass the tables so I see everything away. Means you get more time if you can put it away, and I give it to your table. Quadrants 1 and 2, so the stuff that's shaded up on the board is what I want to see what you know today. Flying girl, you got some around? That guy up? Oh, is this a problem set? So many things going on in my arms right now. One more glance. Not that we're cramming or anything. We were all studying last night. Yeesh. I'm coming. I would like to answer it.
So you only do quadrant
The shaded stuff. One answer.
that is.
I know.
One card.
Then you're gonna really do that. Give it about one more minute. Okay, if you're done, make sure again that you put your pencils and things away, and if you need a pen to check, raise your hand and I can bring you a marker. If you have your own, then you can put your pencil away and switch it out so that you're ready to check. So last call, a few more seconds. Okay, if you haven't already, finish up the one you're on. All those pencils need to go somewhere else because we can't use those while we're checking. No changes. Waiting on just a few people. Huh? You're good? Thank you. You got a pen? Okay. Pencils away. Pen. I'm not going to write them all down. I'm just going to read it. Remember, you're going check, 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 or like check, X, check. At the end, we're going to count up how many little X's you have, right, minus, whatever. Just like we did yesterday, okay? So, different color or a pen if you were using pencil. Here we go. First up, we got 0, 0, and the point 1, 0. 0 degrees is 0 radians, 1, 0. Okay, next up, 30 degrees, pi over 6 radians, root 3 over 2, comma, 1/2. Next one, 45 degrees, pi over 4, root 2 over 2, root 2 over 2. Next one, 60 degrees, pi over 3 radians, 1/2, comma, root 3 over 2. Up top, 90 degrees, pi over 2, you're splitting it in half. So remember, not just memorizing, but think about what makes sense. And the point is 0, 1. Up next, we are into quadrant 2, different than yesterday for the first time. 120 degrees, 2 pi over 3, it's 2 of the pi pieces. And that point is negative 1/2, positive root 3 over 2. Make sure you have the little negative on the x value. Next up, 135 degrees, 3 pi over 4, negative root 2 over 2, positive root 2 over 2. Next one, 150 degrees, 5 pi over 6, negative root 3 over 2, positive 1/2. Last but not least, pi 180 degrees is negative 1, 0. Cool? Questions? Okay, so count up how many little x's you have and write minus however many. And then if y'all can make sure you don't confuse these with the ones from yesterday and make one pile of these new ones. And who's question? Juan, do you mind walking around here?
I forgot that we have to do like the most simplest form on pi over 4. No, is that pi over 2?
That's fine. As long as it's equivalent, that's fine. Okay? Alright, so you're going to turn those into Juan from your table. I know you have a lot of papers at your table because I passed back quiz from Friday, the unit circles from yesterday, and any problem sets that y'all gave to me. So make sure you get those papers and don't leave any behind. You also have your due first, so we're going to go ahead and go back to our due first, which is going to be our review for the common assessment. Listen as Juan's walking around, and as you're getting those papers, keep listening up here. So here's how it's going to work. I'm going to wait till everyone's kind of settled in their eyes up here. Question?
So you couldn't have a red
Huh?
So you couldn't have a
Okay, good question. Okay, so on number 3, okay, I pull, like a lot of times for these quizzes that are like the first one, I'm pulling questions from a lot of places. And I pulled a question, and the answer that was correct, the person actually did not simplify all the way. So they left a square root on the bottom. So if we simplify, we talk about moving the square root to the top. And so when I saw that, like after y'all had taken it, I was kind of like, oh, that's going to throw a lot of people off. People are going to like eliminate all the answers that have square roots on the bottom. But when I actually went through and graded, I had majority of the people that had it wrong circled like A and B, which is like square root on the bottom. So like people didn't use that rationale. I know some of y'all did, but like I counted for in the grades, a lot of people's grades are still fine, so I didn't completely throw the problem out. So know that on like multiple choice, on a free response, I've set the expectation that in order for y'all to get full credit, you need to remove square roots to the bottom. But there are equivalent answers. Like you should not have found a correct answer that didn't have a square root on the bottom, right? And it's like looking at a multiple choice in 6th grade and like they leave an answer as like 3/6, and that's equal to 1/2. And if you were doing it on your own, you would simplify, right? But that's equivalent, and so we should still know that that one's the same, okay? So I apologize. But know that I checked up on that and with the grades, and I didn't mean to throw people off and put like trick question, gotcha. But I know that was kind of like a little messy, so my bad. Anything else about that one? Okay. Yeah.
Can you explain how to do it?
Yeah, in general, those are similar to, like we did another one, I think, yesterday, kind of like that. So which one, what did it give you? Sine.
Yeah, theta is an angle in the second quadrant such that sine theta is equal to 2 over x.
Okay, so sine, eyes up here. Which quadrant are you in?
Second.
Second one. And so we're drawing a triangle in the second quadrant, and sine is 2 over x, which means we've got opposite 2 and hypotenuse x. And then if you do Pythagorean theorem to solve for this side, you'd have 2 squared plus b squared equals x squared. And if you're solving for this side b right here, this would be 4, so b squared equals x squared minus 4. Take the square root. This is equal to the square root of x squared minus 4. Okay? And then they want you to find which trig function? Tangent. Okay, now think about if we're in this quadrant, let's think this would be positive 2 up, but if this is back, remember when we take the square root, it could be plus or negative, and that would have to be minus. And tangent is the opposite over adjacent, so we'd have 2 over negative square root x squared minus 4. Okay, cool. So just labeling your triangle. You should definitely probably be shown some math on one like that, like drawing your triangle in the right quadrant and all that good stuff. Okay? All right. Good question. So from now on our do first, just as a heads up, I'm going to be trying to roll in some CA review because since common assessments are next Friday, we are only going to have a few days to review, not as many as I would like because we learned a lot of stuff this year. So I'm going to be starting throughout this week and next week until we get to our review days, doing our do first as an old problem from any of the units. And then I'm also going to send home with you so that you guys feel set up for success with practicing. I'm going to send home a take-home problem from now on, because this is our last 2 weeks to push through. That's one multiple choice problem. If you're pacing yourself on the common assessment, that should be under 3 minutes. So I'm asking yourself to devote for the next week and a half, you can do it, under 3 minutes of your night to try one more problem to just make it a little stickier. You never know when you're going to get a problem that's going to be the one that looks really similar to something that you're going to see, and the fact that you did it ahead of time is going to help you out, right? So this problem today that we're doing with function compositions, I'm going to send them home another Unit 1 function composition question for you to come back with tomorrow. Tomorrow we'll do a Unit 2 question, and then we'll really quickly check the answer to this, and then move on. So you'll get 2 questions a day leading up to the common assessment in addition to our review days. All right? All right, so this first one, if we have f of g of x, if y'all remember, composing 2 functions just means that we are plugging g of x in to f of x as our input. So if f of x is the square root of something, x, that you plug into the square root, then I'm going to be plugging in some function g of x, and then it looks like this. So what do I have to be plugging in here? Which of these answer choices would make sense for me to plug in underneath the square root to get something that looks like that? Jose? A. I would plug in this pink part would be my g of x. If I plug that in, then this would be f of g of x, right? Okay, so that was a kind of level 1, kind of easier function composition problem, okay? I'm going to send home another one to look at. This one is going to also include function compositions, but also something else from Unit 1, whether the function then is even or odd. So if you're shoot, I don't remember what an even or odd function is. One thing I recommend is, I know not everyone keeps their thick notes packets because we've got a lot of those, but hopefully we've been keeping those unit reviews, those one-sheeters I gave you before the test, has those main definitions, Branda's got it, and it has formulas and stuff. So it'll have on there, if you're I don't know what an even or odd is, look at unit 1 and look up what an even odd is for tonight. Come back tomorrow ready to go. Cool? Okay, so go ahead, put all this stuff away. I'm going to pass out the take-home one. I know you got a lot of half sheets floating around. My bad, just trying to stay fit for y'all. Don't want to do a full sheet. Pass those out. This is your take-home practice for the CA. Rolling in that review. And then we're gonna grade it together. It's like an unofficial grade. So to be honest, I can't handle like accounting for like who did it and who didn't. And so you're not gonna get a whole lot of consequence if you don't. But I'm asking you that if you want to do well on this, to put in a little time one day at a time, because a couple days next week is not gonna be enough to recap everything we've done. Okay. Alright, so now we are finally at the point we need to be for today. We're going to be talking about the last few lessons over the next few days. And today we're going to talk about inverse trig functions on the unit circle. So, we have been doing a lot of problems, like I've had them as the do first the last few days. I know it's 8th period, stick with me, y'all. Sit up, we're like close to the end of the unit. Some of y'all, I remember like unit 3 wasn't so hot for some people. Some people are counting on unit 4 to help them out. So this is, stick with me. We've been doing a lot of problems where we've been saying, for example, sine of pi over 4 equals what? At this point, we should be able to also just think about that rather than looking at the unit circle. Remember that yellow paper can't go with you to your quiz on Friday. So everyone picture where pi over 4 is. Since we've been doing these quizzes, we should have a good idea. We should be picturing something in the middle of quadrant 1, right? And then sine is y. So you should be picturing the y coordinate right here. Who's got it without looking at their yellow paper? What's this? Good. Okay. So we should start to be able to do those in your head. Now notice, what I gave you was the angle and the trig function. You gave me like a ratio of sides, or like an x or a y, something that came from those right triangles that we drew to make our unit circle, right? Okay, so today, what I'm going to do instead is give you a problem like this, where notice it says explore, identify any angles. This time, I'm not giving you the angle, you have to find the angle. When I give you the ratio of the sides, I give you the answer 1/2, and I want you to tell me what angle is sine equal to 1/2, okay? And then for the second one, I want what angle would give you sine equal to negative square root of 2 over 2. I want you to skip 3 and 4 for now, for time, because we did all that stuff at the beginning of class. So really quickly, turn it up with your neighbors. I'm going to give you like 1 minute to try to find the angles that make these sine values. Go.
Talk to your neighbor.
You don't want these 3 for tomorrow?
I have them.
I know you guys. This isn't even mine. That's why. Are those the notes?
I got it.
So you can leave it like that, but you probably aren't going to know that data, right? Right, like we don't have.
Yeah.
So what I'm asking you is to use your unit circle. You know that sine is what? Y.
That's how they got a lot of questions.
It's like you're not breaking it apart.
I thought sine was x, cosine
All right. Voices off as up here. Okay. Any takers for angles that give us sine equal to 1/2? Justin. 30 degrees. So a lot of people that had on that one, so they say 30 degrees. That is actually the answer that you'll get in a second when we are doing this on the calculator. That's the answer it'll give you. But did anyone find any other angles that work, Jose? 150 degrees. Anyone notice that in quadrant 2? Sine is also positive, so it's also equal to positive 1/2 over here. So I saw a lot of people that wrote 150 as well. You could do any of these in degrees or radians. I've noticed a lot of people doing degrees, so I'm just going to stick with degrees too. Did anyone have any others? Isaiah?
390.
Let's check. Yeah, so 390 is a coterminal angle for 30 degrees, right? So technically, I could write unlimited number of angles, not choosing any angle I want, but I could add 360 to either of these or subtract 360, and I would be in the same location, which means I'd have the same right triangle, which means I'd have the same sine and cosine, right? Okay, so that's going to cause an issue for us kind of in a second, because when I ask for the angle that gives us sine equal to 1/2, like technically you could list angles all day, and so we're going to talk about how we get like one answer here in a second, okay? What about, let's recap really quickly, -√2/2, yep. 225, and then the other one I saw a lot of people get was 315, and then any rotation circles of that, right? Okay, so this would be what and you didn't have to have like all of these, we're just saying the point is that there's actually a lot of them. Most of y'all probably got 1, maybe 2, okay? What we're doing is we're thinking backwards, right? We're saying sine of theta equals 1/2. What is our theta? We're trying to like switch right here, our angle and our side lengths. And we've actually done that before, right? Where if we want to switch our input and our output, if you want to switch your input and your output, what do we call that with a function, Maggie?
The inverse?
The inverse, right? It's like if you switch x and y, if you switch your independent and dependent variable, you are finding the inverse of a function. However, big news. Stick with me. 1. Okay. However, remember with the inverse, functions that have an inverse have to be 1-to-1, which means every y gives you 1x, every x gives you 1y, right? Remember all that vertical line test, horizontal line test, all that good stuff? And if you look at this problem, if we think about this as sine inverse of 1/2 equals theta, and we switch them, right? You gave me more than one answer. That's a problem, right? We've got more than one answer, and it needs to be 1-to-1, not 1 to like 5 answers, right? Okay, so we need to restrict for the inverse function, sine, cosine, and tangent. We're going to talk right now about how we are going to restrict our like domain and range and only look at a part of the unit circle or a part of our function when we're finding the inverse. So we know which quadrant to look in, and we don't list all angles, we should just have one, okay? So let's take a look right here, and we're going to fill out some things about our inverses in these boxes that follow. And this talks about specifically inverse sine, but I'm going to kind of summarize for the sake of time right here. So let's start with inverse sine first. The way we write it, notation-wise, pick up your pencils, no taking time. Carmen? The way we write it is sine inverse with the little -1. And there's a number on the inside, sine inverse of something equals something else, some other number. So I'm going to say sine inverse of A equals B. You can always plug them into the calculator, and we've actually done sine inverse, y'all remember? When we had to solve for angles. And we were given O and H, and we had to solve for theta, right? So theta is that thing that we're solving for. And we use the calculator, and you can use the calculator. But what we're going to be doing today is focusing on a non-calc section where we use our unit circle to like have it memorized in reverse. Cool? Okay, so if we write it like this, the other notation for it, there's another way you could write it that you haven't seen, that is not on your calculator, but you'll see typed out. This arc sign means the exact same thing as the little -1. Arc sign and sine with the -1 both mean inverse of sine. So I'm going to read both of those as inverse sine of A equals B. In this case, to point out, let's make sure you get in your notes, B represents what? What are we solving for? I heard someone say it?
Theta.
The theta, the angle, the degrees or radians, you can write it in degrees or radians, but regardless, our answer, our output is the angle when we're dealing with the inverse, and then our A, our input, is like the ratio of the sides, which in this case, if we're thinking about the unit circle for sine, we know that the sides of the triangle for sine, it's talking about like y over 1, or we keep saying that sine is y, right? So notice we put the y, we put the 1/2 inside, and the theta is on the outside. So you can think about this as y for sine. Okay, so if that's true, we run into this issue of the fact that we could list a lot of thetas. So they restrict sine, inverse sine, to just the fourth and the first quadrant. If I were to draw my unit circle, we're only going to be looking at basically the right side of this graph. You getting that? And processing, right? Because like if you're just copying this down, it's not soaking up in your brain. So wake yourself up, do whatever you gotta do. I know it's 8th period. Stick with me. Okay. I'm going to write out also for us, just so we have it in our notes, what that means for our domain and range like of this function if we're only looking at that part of sine, of for the inverse sine function. But you won't have to write this domain and range a lot, so don't stress too much if it's kind of confusing. But try to stick with me and kind of understand it. All right, so how would I describe the range or the angle, the smallest to the biggest for the angle? Now, if you look right here, we want this side of the circle, right? And this is 90 degrees. What's down here? 270 is how we would think about it, right? But let's think about that. If I'm writing a range, it has to go from biggest to smallest. From smallest to biggest, right? It has to get bigger. So I can't write 270 to 90. That doesn't make sense. I need to go from least to greatest. But if I say 90 to 270, that makes us think this side of the circle, right? From 90 to 270. So I'm going to rewrite 270 actually as a negative 90 degrees. Do you agree it's 90 degrees backwards? And I'm just going to write this, the way they'll write it is you'll see it as negative 90 or negative pi over 2 all the way up to positive 90 or positive pi over 2. So whenever you are listing inverse sine, if you want an angle in this quadrant, you actually will not say 270 degrees, you'll say negative 90 degrees because we need it to be in this specific set of angles. We don't want any coterminal angles that are outside of that, right? To get to, for example, 315, I would have to go into the bad zone. So for 315, I'm going to call it negative 45 degrees, 45 degrees down, okay? Okay. For our range, for our domain, that's coming from A, which if we think about our unit circle, A is our different sine, our different y values, right? We're looking at our y coordinate right here, right? Which goes from the lowest is down here at negative 1, and the highest is up here at positive 1, right? So we're going from negative 1 to 1 for the input or the A value here in our inverse sine. Okay? Okay. That was a lot of time for the first one. Let's go a little faster for the next few. So now let's go on to cosine. Inverse cosine of A equals B is the same thing as if you see arc cosine. Okay? That means the same exact thing. Just like before, B is our what? Angle. And that means A is the ratio of our sides, but for cosine, this one, let's say it was cosine inverse of a half, the half would represent what? For cosine. For sine it was y. We were looking for where y was 1/2. For cosine we'll be looking at the sides, of like x, right? It's technically x over 1 because it's the x over the radius of 1, but we call it x. Okay. Okay, and for cosine, we're going to be looking, again, we have to restrict it, but for cosine, you'll notice that if we use these two quadrants, we have the issue of some repeating values. Like over here, you have cosine inverse of root 3 over 2. You'd say maybe 30 degrees, but then root 3 over 2 is also down here, right? So we can't use these two quadrants. So for cosine, we're going to actually use the top of the circle, quadrant 1 and 2. Okay, so domain and range. Our range this time is a little easier. Just going to go from 0 to 180, and you don't have to do any weird negatives because that goes in order. And then for your domain, we're thinking about these a values, these x's, and if you look at the furthest over x, and the furthest over x here, it goes from -1 to 1 again. This side of the circle goes from -1 to that side of the circle 1, right? That's the furthest over cosine value. So if I ask for cosine inverse of 5, is there ever going to be an x value of 5? No, that would be way over here if this is a positive 1, way over here. So that would be does not exist. Like automatically, if you plug that into your calculator, it'll give you a does not exist, like, okay? Okay. So it only goes from -1 to 1. Last one, tangent. Inverse tan of A equals B. You can catch on by now. Arctan of A equals B, where B is our angle. And let's think about A is going to be the ratio of sides, which this one looks more like a fraction. What do we do for tangent? Y over x, right? So it's a ratio of y, the opposite side, over x, the adjacent side. All right, so looking at your circle, tangent is going to be the same as sine. It's going to be over here. So the only one you really need to remember is cosine. All of them are going to be in quadrant 1 and 4, except for cosine is the one that's in 1 and 2. Okay? So, yeah. So the only one you need to remember that's weird is cosine. Cool? So then, domain and range. For our range, we've got, again, this negative 90 to 90, except I'm going to put, just as a side note, I'm going to put parentheses this time, because technically if you check tangent at 90 and negative 90, you'll see it's undefined. Remember, you get 1 over 0 or negative 1 over 0. Ratio of the sides, y. Okay, and then domain. This domain, I'm not going to go into it for too long, but I can one off with you, is actually going to be negative infinity to infinity, because it's not restricted by like the radius of our circle, right? Because it's not x or y. X or y only goes out, x goes out 1 backwards and forward, y goes up 1 forwards. But if we're dividing y divided by x, like if you divide square root 3 over 2 by a half, you get the square root of 3, which is bigger than 1. When you start dividing fractions, you can get numbers bigger than 1, right? So we open up a whole bucket of new answers. Okay, so let's take these and go ahead and solve some problems. So first 3. First one, we actually have already done now multiple times. The inverse sine of 1/2. That's that original problem we did, right? We said what angle will give us y or sine equal to 1/2, and y'all said 30, 150, 390, right? But only one of those we want to keep when we're talking inverse. So looking at our quadrants, what is the only one that would fall in quadrant 1 or quadrant 4? What's the only angle that would fall in quadrant 1 or 4 that would give us sine of 1/2? Maggie? 30. The only one we would keep was 30. Like the 150 no longer works, and so when it's 390 doesn't work because I would have to go around the circle full time and I'd have to go into the bad land, right? Okay? So we got 30 degrees only. Isaiah, you see why 390 doesn't work for that one?
Yeah.
Okay. Okay, next one. Sine inverse of 1. Can someone explain to me how we like translate when we see that? What are we looking for? Like for this one, we were looking for the angle where y was 1/2. So what are we looking for here? Maggie's with me. I already been calling on her. Jesus? Just what? But what are we? In case someone's like, how did he get that? Like, can you? What did you look for?
Well, I look for sin the y. Y where you know where it's y over there?
And what do we want y to be equal to?
1.
1. And y is equal to 1 up here. Y'all see it? And so he wrote 90 degrees for that one. Cool? Alright, and then last one. This is where things get weird. I want to throw this in here because it's kind of a trick. Remember how I mentioned that cosine inverse of 5 does not exist because this number is too big for like the possible values of x, right? Okay. So looking right here, they say sine inverse of negative 2 pi. When you guys see 2 pi, what are you thinking? Bad. Don't think that. But I know why you're thinking that because we say 2 pi automatically. Y'all go to like the land of angles and you're like 2 pi is equal to 360. I know where it is and I'm going to write down y. But is this an angle if it's inside? So this is not radians. This is just a value that's inside, which means it's a ratio of sides. They're saying, where is y, the side length, not these angles in the middle, where is y, the side length, equal to negative 2 pi, which is equal to about negative 6. Because like 2 times 3, 3.14 is like about 6. So they're saying what angle would give us a y value of negative 6? Do we have anywhere on our unit circle where the y goes all the way down past negative 1 to negative 6 down here? Does not exist. So do not, when you see pi's, assume that it's an angle, because remember, if it's an inverse cosine or sine, you are solving for the angle. They're not giving you the angle. You would have to be writing down the angle. So for inverse, sine, cosine, and tangent, these things really shouldn't have pi's as in radians. If it's a pi, it just means 3.14 like that number times 2, okay? So don't let them get you with that. All right, on to these 4. I want y'all to try them out as practice. See what you can come up with. They're going to get a little harder as you get to tangent because you have to divide y over x and see which one gives you negative 1 and which one gives you root 3. Go for it. Try it out. Did you do 1 or 2 yet? Do 1 or 2 of them, and then I'll check them, and then you can go. You're done.
Can you explain this one to me?
So, if we translate it the same way as these, you're saying at what angle? Wait, this one's 90. Right? At what angle will y equal 1, right? So if you translate this the same way, you're saying at what angle will y equal negative 2 pi? So you're thinking where on your unit circle, not is the angle 2 pi, where is the y value equal to 2 pi, but negative 2 pi, sorry. And like the furthest y ever goes down is negative 1. Negative 2 pi is roughly like negative 6, so it's way down here. What they're hoping is that people will see this and think like, oh, that's an angle, and do this problem, not an inverse sine, and they'll go to negative 2 pi, which is going back the circle, and you end up here, and they'll write down the y value as 0. But that's this problem, not an inverse problem, right? So when it's an inverse, you have to interpret that as like a value, not an angle. Okay? Okay, so this, think about this as when we're translating again, like you said, where is x equal to this? So you're saying where is y divided by x equal to negative 1? Because remember, that's tangent, is y over x. So if you were to look all the way around the circle and divide y over x, 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 so see which one gives you negative 1. So like here you'll get 0 divided by 1 is 0, so find out. Well, that would be if you, but that's not equal to -1, right? That would be 0. So you're looking for one where, so notice in general, Diamond, focus for me. Thank you. The only way you're going to get 1 in general when you're dividing is when you divide a number by itself, right? Like 10 divided by 10, 11 divided by 11. Or for example, here, if you divide root 2 over 2 over root 2 over 2, but here you would get. But which quadrants are you in? So you're looking at. Make sure you see at least about 2 of them by now. Okay, good. This is why we're so the testing is only glancing at unit circle. It's not as easy as just scanning for a -1, right? You have to do some division. So for example, here, if I'll start to write the tangent as you go around here, what answer would be 0 divided by 1, which is what? Okay, here, tangent would be 1/2 divided by root 3 over 2, which is some number, I don't know, you can find it, but something not that, right? What about root 2 over 2 divided by root 2 over 2? What's any number divided by 7? So this is going to be 1, but that's going to be a 1. You want them to be the same, but one of them has to be negative. And which quadrants are we in?
That one would give me a yeah.
So you're looking either here, or looking at these 2 quadrants. So you can do
I'm being serious.
No, so when you're looking for tangent, you're looking for y over x, right? So technically you would have to put it here and you would have to calculate tangent because tangent's not on there. Tangent here is y divided by x would be 0 over 1, which is 0. Right? And so that's all that. So here, you have like 1/2 divided by root 3 over 2. Okay, so that one. If you do this division, see if you get root 3. If you don't, then keep trying. I think it ends up in this. Okay, we got 3 minutes left, so I'm going to check what you got, see how we ended up. Any takers for the first one? They get a little harder, so take your chances now. Carmen. 135 degrees, or if you write it in radians, 3 pi over 4. But those are the same.
That's you.
Thank you. Next up, Miranda.
It doesn't exist.
Does not exist. This x will never make its way out to 2. Okay. For the next one, you're looking for a -1 where y, when you take y and divide it by x, you get a -1, and this one's a little trickier. Jeannie, what'd you get?
-45.
Okay. Perfect.
What?
I know some of y'all, pause, because we're running short on time.
Oh yeah.
I know some of y'all wrote down,
I know, we need that right now.
don't back up. I know some people wrote 315, and I'm gonna for today give you like 90% credit because I know what you're talking about. You're in the right spot because when you divide these, you get -1. However, remember, to get to 315, you would have to technically go all the way around the circle, and as soon as you get here, we hit that wall, right? We only can go either up or down on this side of our circle. So we have to write 315 as -45 to be in our possible range of values, okay? So that's kind of a tricky one. And then the last one, you end up getting 60 degrees or pi over 3. When you divide root 3 over 2 by 1/2, you get root 3, but that's a tough one, okay? Yeah, the division is not hard, but just seeing it since it's not on your unit circle, people are like, oh, where did random root 3 come from? Okay, tomorrow we will wrap up one more thing with this that we didn't get to, and then we'll go on to law of sines. Yay!
Wait, what?
Bye-bye! Stack your chairs. Please don't leave my, like, random first.
answer that question. Well, it's not a